Topic is artificial intelligence and machine learning in agriculture as well as apiculture. So we are all know agriculture is the backbone of our civilization since the dawn of agriculture. So since the dawn of our civilization, and with the growing global population, it's projected to reach nearly about 10 billion by the year 2050. So with this huge growth of population, we need to provide a lot of food. So now the agriculture has taken a major role. So with less imports, we have to grow more. So in that situation, we are here, and FAO has already predicted. So the global production would be increased by 60% by the year 2050 to feed this enormous population. So to achieve this, we are facing environmental concerns, reducing carbon emissions, and improving the efficiency. These are the three major criteria in achieving this goal. So we have a lot of challenges in reaching this. As we are aware that the Indian agriculture is it's a challenge between the monsoon as well as agriculture, and it is a major threat is climate change. So because of the most unpredictable weather patterns, lot of droughts and floods, which have the greater impacts on our crop yields. So if you take for example, in our Karnataka, if you observe for the past 10 years the data, we have faced 6 drought years. Out of 10, 6 are the drought years. Only 4 we have received sufficient rains. So in such a situation, how to achieve this goal? Second one is resource limitations, scarcity of arable land, fresh water, nutrient affects the food production. So scarcity of arable land is a major threat. Nowadays, all people, we are well aware that all our cultivable lands are being transformed into residential areas. That means to say the sites or flats or apartments are being built up in these areas. And apart from residential areas, there is a huge demand for establishment of factories as well as the urban infrastructure and highways. So a lot of arable land is being converted to non-agriculture sector nowadays, and only we have very limited area to grow these things. So fresh water, we are well aware. So we are not in a position to provide good drinking water, quality drinking water. Then from where we have to bring water for agriculture or horticulture purpose. So nutrient effects, pest and disease. So nowadays, yes, newer crops coming to our area, lot of pest and disease, most devastating pests, as well as the invasive pests, the problem we are facing. So apart from our traditional pests and diseases, we are also facing lot from invasive pests threatening. So labor shortage is one of the major criteria in almost all the part of our country, apart from supply chain inefficiencies. So in India, we have lack of post-harvest, the proper ways for post-harvest to avoid or prevent post-harvest losses, immediate transport to the local markets or the volatility of the markets, and food waste remaining the major issues. So these are all the concerns in agriculture for achieving higher yields. So let's coming to our topic. So what is artificial intelligence? So it is a very broad field of computer science focused on creating systems or machines that can perform tasks that typically require human intelligence. So these tasks including reasoning, problem solving, perception, language understanding, and learning. So we should be well aware at this stage. So till we formulate this artificial intelligence or the any machines for operating on behalf of human beings, we are the supremes. Once we hand over the intelligence to these machineries, so they take over us. So this care has to be there in our mind. So it is a must. So it encompasses a wide range of techniques and approaches, including rule-based systems, expert systems, robotics, natural language processing systems, and many more related things. So this has become a revolution in several industries, including agriculture. So in recent years, artificial intelligence technologies have been incorporated into agriculture practices, transforming traditional farming methods and enhancing the efficiency, productivity, and sustainability. So we are well aware that apart from agriculture, all the other sectors we are using artificial intelligence, and very recently we have started using these techniques in agriculture. So, but once we have incorporated this technology, so now everywhere we are seeing how best we can include this technology for increasing our yields. So in agriculture, it involves utilizing advanced algorithms, machine learning techniques, and big data analytics to scrutinize complex agricultural data and make well-informed decisions. So if you just think over, suppose if you say, so what will be the weather next year? What will be the position or what will be the change that we can expect in our climate next year or after 5 years? So whether a particular crop which we are going to plant this year, can we expect the threshold yield after 5 years or 10 years or so? So to make such decisions, we have to take care of the last 10 years data. What are all the climate change we have faced? What are the weather changes that have occurred? And whether it will be suitable after 10 years. So if it is the case, then only we can expect the threshold yield of that particular crop. If not, we have to think twice. So in artificial intelligence application in agriculture comprise of crop monitoring, precision farming, predictive analysis, autonomous farming equipments, and the livestock monitoring. So in my future slides, we are going to learn on all these things, how exactly we are equipping this artificial intelligence in agriculture. So repeatedly, I am using the term machine learning. So what is meant? So why machine learning is a subset of artificial intelligence that focuses on algorithms and statistical models that enable machines to learn from data and improve their performance over time without being explicitly programmed. So here we are going to make programs. So just think of our earlier days. So when we were younger ones, or 10 years ago, or 20 years ago, if you want any data, so we used to hear from our elders, our seniors, our age-old farmers. So because of their experience, they used to teach us what will happen if you are going to sow this particular seed, or if you are going to plant this particular crop. So with their experience, they used to say, but now the situation is not like that. If you just feed or if you just ask for the system or a computer, so the Google immediately gives so many alternatives. So this is the advancement. For this advancement, we need to make all the algorithms and statistical methods, and we are doing it. So this machine learning specifically deals with the training models using data so that they can recognize patterns, make predictions, and classify data. It's more about enabling machines to learn from examples rather than being programmed with a fixed set of rules. So in agriculture, nothing is a thumb rule. So just by doing so, our forefathers were doing this particular crop. I am going to do this. No need of that things. So if you just think, if you want to do particular experiment by importing some of the seeds from other states, take for example from other states, but can we grow that particular crop in this area? For example, a Kashmir apple importing to Karnataka. So can we grow apple in Karnataka? If you just program it, so what is the weather condition at Kashmir and what is the weather condition prevailing in Karnataka? So if you just give the comparison, immediately our machines are able to analyze and say whether it is profitable venture or non-profitable venture. So otherwise, you have to take time, you have to go and study at Kashmir, then analyze your data, and then you have to compare with our local data, then you have to decide. So now it is not at all needed. By just clicking on a single button, you will get all the data. So what will be the chronology of this artificial intelligence, machine learning, and deep learning concepts? So the artificial intelligence teaches us the technique of making intelligent machines and programs that mimics human behavior of problem solving. So this was the era in 50s. So at those days, we were thinking of establishing a system which can think exactly like a human being. So from those were the days a human was thinking, so suppose if I have one machine which can think exactly like me, what will be the thing? So later on 1980s, the ability of the machines to learn without being explicitly programmed. So just by capturing the data, the machines were able to analyze the data. That was in 1980s. So during the 80s, we were able to advance our systems to that extent. So now we are in an era where the learning the patterns automatically from the large data set. So now we don't need to say anything, just by providing the data, by just by capturing the data, every analysis and various options will be provided by directly by the machine. So suppose take for example in agriculture, how best we can use. So machine learning we are using for crop management, wherein which the data points can analyze on various weather patterns existing in the locality, soil quality of a particular various, it is not not only the quality, we can say the various parameters regarding the soil and crop attributes. So by combining all the three weather parameters, soil quality and the crop attributes, we can analyze what crop or what the threshold will we are going to get after few future days. So similarly, the computer vision for the plant health monitoring. So here the cameras will do the thing. They will capture the plants and they can segregate our data to healthy and non-healthy plants, making so many attributes and the signatures available on the plant or leaf, whatever the exhibits we are providing. Based on that, the standard comparing, keeping it with the standard, it compares whether it is a healthy plant or non-healthy plant, whether it requires any treatment or not requires any treatments. So likewise, it can analyze and give the information on the plant health. So similarly, we have a real-time data collection. So soil, various parameters of the soil, temperature, humidity, what are the abiotic factors prevailing around the soil or prevailing around the plant, we can easily get the sensor-based information. So here we have the advancement with the soil temperature, prevailing relative humidity, leaf temperature. So likewise, everything will be compiled and give in a either in a chart form or in a Excel sheets. So we can, whenever we can get, we can segregate the data in any format of our choice. So similarly, we are using the robotics and the drones in farming. So it's a robotic application or where in which the humans have no hand in operating these things. So unmanned things, unmanned drones or robotics we are using, unmanned aircrafts we are using. So the key technologies which we are using in agriculture, that artificial intelligence technologies we are using. So here the some of the factors are machine learning in crop management. So where in which they have the predictive models which can analyze huge amount of data such as historical weather patterns, soil quality, and crop attributes. So these models provides insights into optimal planting times, crop varieties, resource allocation, assisting farmers in making informed crop management decisions. So it is all total as a the complete crop management from seed to seed we can call. So when exactly to the sowing operations to be needed, what exactly the land preparations to be taken, which varieties to be selected, what are the resources or the inputs to be given. So what, when to spray, how to spray, how much to spray, what is the exact time required for spray, when the pest or diseases reaching the threshold level. So all these things will be assisted by the system. So similarly, the computer vision for the plant health management, apart from the crop management, the very specifically for the pest and disease, we have the computer vision systems using these cameras and the image analysis system for detect the insect pests and nutritional deficiencies. Early detection allows farmers to take corrective actions, decreasing crop losses and need for chemical treatments. So India being a developing country, so we have seen still the farmers rely much more on the input dealers rather than any department officials or the scientists. So it's very shame to say, but still the thing is going like this. So still the farmers either they are depending on the local dealers, input dealers, or a neighboring farmer. But still we can see they can't differentiate between a damage, either it is through a pest or it is a disease, or if there is any nutritional deficiencies which creating these stresses. So if it is fed to a system, if it can be analyzed through a system, then exactly because of the spectral signature of each individual, exact identification of the root cause will be given by these machines, and farmer will be properly guided, and he can take the control measure according to the suggestions. Because many a time we see the gambling with pesticide dealers. So if they can't identify a proper route, they give one for the sucking pest, another chemical for the controlling any contact pest, or chewing and biting type, or a contact insecticide. Another chemical they provide for a disease control, and one more tonic in the name of tonic they supplement for the nutritional. So they give all the choices and plant has to select, but it causes the financial crisis for the farmer. At the same time, huge quantity of the poison is being dumped on the soil. So just imagine the situation of soil in such cases. So similarly, the Internet of Things and sensor technologies, these devices and sensors capture real-time data on soil moisture, temperature, humidity, and other variables. So these artificial intelligence uses this data to generate actionable insights, allowing for more precise irrigation and resource management. So just by installing these proper sensors, we can gauge when to give the nutrients, when to give irrigation, whether the given irrigation is excess or limited or optimum. So we can take such decisions immediately and in real-time basis. And similarly, we are using robotics and drones in the farming. So various operations are being done by these drones and robotics, like planting, weeding, harvesting operations performed by autonomous farming equipments. This is very important, where in which the operator is not at all required, or he can just play with the buttons. And drones with AI-driven systems. These technologies improve the efficiencies and reduce labor cost and improve precision in various farming tasks. So according to the Food and Agriculture Organization, precision agriculture technologies, including artificial intelligence, have the potential to increase global crop yields by 20%. So if not a 20%, even if it is just 5 or 10%, then also we will be very happy. Any marginal increase over production of earlier production is beneficial in our field. So we have so many prediction model, how much where we can reach and what are the things we have reached or achieved till date. So if you just compare with the 2023 and 2031, the prediction goes. So in crop monitoring, yield prediction and others. So the end user application is farmers, how much they adapt, cooperatives and others, how much the artificial intelligence going to accumulate their minds in future. So this is again growth in terms of finance. So coming to the role of artificial intelligence in agriculture. So we were telling about crop monitoring and management. Here comes the prediction and predictive analysis for crop yields. So especially everyone is worried about yield, how much I am going to get, how much quantity I can sell, how much quantity I can store, whether the crop at the end stage, whether I am going to get the optimum quantity or what. So here, if you just observe, the technology is machine learning and data analysis. So where through which we can analyze our crop yield. So here the predictive analysis uses historical and real-time data on weather, soil condition, crop health, and other variables to forecast crop yields. So based on earlier experience and comparing with the real-time data. So take for example, 10-year-old or for the past 10 years, what was the weather condition prevailing in the local situation? What was the soil condition at that stage? How was the crop health during the date, same time, same year? and other variables. So maybe the moisture or the rainfall, biotic and abiotic factor taken together. So by comparing earlier as well as the real time, it can forecast the crop yields. So farmers can make data-driven decisions, plan for optimal harvest times, and adjust strategies to maximize yields while reducing uncertainty. So majority of the farmers will be predicting, suppose if I plant in the month of November, suppose if I going to get harvest by March 15th, so what will be the market price? What will be the market demand? So based on that, he has to make decisions. So by adopting this predictive analysis model, so he can easily gauge when exactly he can harvest the crop. So based on day-to-day actual data, real-time data, he can predict whether the harvest time is going to be delayed or the harvest time is going to be earlier, preponed. So based on that decision, he can make marketing arrangement. So similarly, the soil and environmental sensing. So here the technology we use for these things is IoT sensors, drones, and satellite imaging. So by deploying these sensors in the soil and environmental monitoring devices, which can collect the data on soil moisture, temperature, nutrient levels, and weather conditions. So all these four parameters can be gauged by these sensors by deploying them in the farm field. So this data generated out of this can be used to determine best planting times, irrigation schedules, fertilizer applications for optimizing crop growth and resource utilization. So these sensors will give when to be irrigation to be scheduled, when you can schedule for the fertilizer application, when we can predict the forthcoming pest and diseases, what preparations you need to make. So based on these all analysis, a farmer can take easy decisions. So he need not go to anyone, and by himself, based on his own field, he can make out the decisions. So many a times what farmers are doing right now, suppose if a farmer from the far off places or a neighbor farmer or maybe a farmer in the next village, if he is applying any fertilizer or if he is applying any plant protection chemical, this fellow is also going to apply. But by deploying this machine learning systems, he can analyze his own field condition. So he can make decisions based on the conditions prevailing in his own field. See, in Indian condition, what happens? Suppose if the farmer is having 10 acres of land, each acre the condition varies. So probably many of you might be knowing. So the condition of the soil type prevailing in one block may not be the same exactly, may not be the same in another block. The moisture content, moisture retention capacity, or the soil nutrient condition, it differs from field to field. So in such cases, if he wrongly takes any decision, it is just a burden on his pocket as well as on the soil. So similarly, the detection of disease and pest. So here we use the technology for computer vision, artificial intelligence, and remote sensing. So these artificial intelligence powered cameras and sensors, they monitor crops for signs of diseases, pests, and nutrient deficiencies. So remote sensing over a large area can also identify these potential issues. So the data which converges together, so they give the real time actual happening, what is happening in the field. So based on that changes in the crop canopy, easily we can sensitize whether it is an occurrence of the disease or occurrence of the pest, or whether already the pest has invaded our field or not. So it compares with large area, the surrounding fields, and it compares with our actual field and give the real-time data. So based on this, we can make early detection, which allows the target intervention, reducing the need for chemical treatments, preventing the spread of diseases or pests, ultimately preserving the crop health and yield. Suppose if the farmer gets any invasion of any new pest to our village, if it is occurring in the border plots, so this farmer can take up early precaution and early necessary action to prevent the entry of such pest and disease to his field. So one of the best concept in with artificial intelligence is precision farming. So it is also known as a precision agriculture, which uses advanced technologies to optimize various aspects of farming practices. So AI is important in precision farming because it provides intelligent solutions to improve productivity and sustainability. So here there are three main components of AI assisted precision farming. The one is smart irrigation systems, crop diversification and rotation, data-driven decision making. So these are the three components which we use in precision farming to take up any decisions. So here in case of a smart irrigation system, the sensors are deployed to study the moisture level, moisture content prevailing and the temperature and humidity prevailing in the surrounding area. So based on this, need for irrigation will be decided. So similarly for crop diversification, the artificial intelligence analyzes the historical data, soil health, and market demands. So it combines all the three and analyzes. So based on its analysis, whether the previous crop, which is the previous crop, what modifications we can do. So what is the soil health condition prevailing? Suppose if it is a cereal is placed for this year, so whether we have to go for oil seed or a pulse crop. Suppose if we go for pulse crop, what will be the future market demand? So whether there is a local demand existing or not. So which is the best option, whether it is pulse crop or for the oil seed crop. So these decisions will be given based on the artificial intelligence analysis. So similarly for marketing or the decision for the data for the decision making. So these sensors will study the various farms like farm number 1, farm 2, farm 3. They collect the data from all the surrounding farms and analyze. So the machine learning algorithms, they analyze the data and give so what has to be done in future for our farm. So take for example smart irrigation system. So the smart irrigation systems leverage sensors, IoT devices, and AI algorithms to keep track of soil moisture levels, weather conditions, and the crop water requirements in real time. So once the crop is fed, so the type of crop and type of soil, those basic data is fed. What are the critical stages? Suppose, for example, if it is rice. So when need irrigation is required, whether it is during development stage or boot leaf stage or grain filling stage. So what are the critical stages? Based on that, it analyzes based on the sowing time it takes up and after 50 days, suppose if it is a boating initiation. So what is the prevailing weather parameters around, and based on that, it takes a decision. So whether you are going need to be irrigated or not. Similarly for all the crops, because in horticulture crops, they are very vulnerable for irrigation. So when it is required, suppose in case of lemon or citrus, if you give excess irrigation during flowering, then the vegetative growth enhances. If you cut down the irrigation, then the flowering initiates. So such decisions will be easily taken up by the system and it gives. So the sensors placed in the soil measure the moisture levels and collected the data is sent to AI algorithms. These algorithms examine this information in conjunction with the weather forecast to determine the amount of water the crops require. So many a times we have seen the farmer is going to farmer irrigates with all the strain he has taken from morning to evening, he irrigates the crop. By evening, heavy rain downpour occurs. So you just imagine the fate of the farmer at that condition. So since morning in the hot sun, he used to irrigate, but by the evening, by the time he returns to his house, all the thunderstorms starts and heavy downpour occurs. So you just imagine the situation. And many a times farmer thinks it is a rainy season. The rain may occur in 1 or 2 days. But even if it is a week long, a single drop of water or a raindrop will fall on the ground. So what will be the fate of the farmer? So in these situations, the artificial intelligence gives a correct, exact prediction what to do. So the benefits of this smart irrigation system is water conservation. So it ensures the crop receive the appropriate amount of water, thus avoiding over irrigation and water wastage. cost efficiency by optimizing water usage. Farmer can reduce their water bills and saving costs. Many a times, Indian farmers purchases water from the neighboring pump sets. You might be well aware. So for per irrigation, he has to pay something to the neighboring farmers who has dug or driven borewells. So he has to pay. So if he has the exact decision from this system, he can save on those bills. Increased yields. Proper irrigation leads to healthier crops, higher yields, improving agriculture productivity. Apart from all these, so we can also check the incidence of pest and disease with the proper irrigation or adequate irrigation or optimum irrigation. So it is a well-aware fact that we can use this technology for reducing the pest and disease incidence also in our fields. The second thing is crop diversification and rotation. So it refers to the practice of producing multiple types of crops in the same region, whereas crop rotation refers to the practice of changing the type of crop cultivated in a single field over the course of the season. So it works on the principle that ideal crop diversification and rotation patterns. So here the system analyzes the historical data, soil health and market demands. Based on that, it's going to give the predictions which is the optimum crop which we can take up. So the benefits like soil health, different crops have different nutrient requirements, and diversity helps to preserve the soil fertility by preventing the depletion of specific nutrients. So the pest and disease management, crop rotation disrupts the life cycle of pest and diseases, decreasing the need for chemical interventions. Sustainability. Diversified and rotational crops contribute to sustainable farming practices by protecting the soil quality as well as the biodiversity. So these are the major advantages of crop diversification and rotation system. The third one is data-driven decision making. So here the data-driven decision making in agriculture involves collecting, analyzing, and interpreting data from various sources such as sensors, satellites, and historical records. So these AI algorithms process this data to provide valuable insights and recommendations. So it works on the principle data collected from different farm sensors and equipments is fed to the AI systems. Machine learning algorithms analyze this data to offer insights into crop health, yield predictions, pest patterns, and optimal farming practices. So in future days to come, the farmers can engage himself in alternate works and he can watch and view his field in his fingertips. So optimized resource use, data-driven insights enable farmers to optimize the use of water, fertilizer, pesticides, and energy, reducing the waste and environmental impacts, enhanced productivity. So such quick decisions will improve the crop yields and overall farm productivity. Not only the right decisions taken with the help of these machine learning systems can definitely help to improve this yield. Risk mitigation. So data analysis helps the farmers to anticipate and mitigate risk related to weather, pest, disease, and market fluctuations, enabling proactive measures to protect crop and investments. So many a times it happens just by we are in a situation where the farmers takes a chance. So simply they are going to sow. They don't know whether the crop comes, or whether the climatic condition is congenial, or whether he is going to receive the rains at a right time. So just by taking a chance, the farmers are going for so many sowings. But by taking appropriate decisions based on this analysis, the machine learning analysis, the farmer can save the cost on waste investment. So the smart farming equipments. So here the equipment refers to advanced agricultural machineries that utilizes AI technologies to enhance efficiency and productivity on the farm. So one notable example is the development of autonomous tractors and harvesters, which have revolutionized traditional farming methods. So apart from taking decision systems, so they are all the abstract concepts. So coming to a materialistic things, so there are so many equipments and implements which are being developed using this advanced smart farming technologies, so like harvesters and tractors, which saves the time of a farmer, which saves the investment on labors and the time. These machines are equipped with sensors, cameras, and AI algorithms that enable them to perform tasks with remarkable precision and accuracy. And no doubt, these machines are highly sensitive, and they are more realistic and reliable sources for any operations. So we have seen in many other cases too, like electronics equipments, gadgets, so many things we have studied, where in which they perform much efficiently than human beings. So take for example the autonomous tractors. So they are the prime examples how it is how the farming is being transformed over years. So these vehicles are capable of navigating fields, planting seeds, applying fertilizers, even harvesting crops without human interventions. So larger areas are being brought up under this sector now. So thousands of acres are being harvested with precision. The integration of GPS technology allows these tractors to follow predetermined routes, optimizing the use of resources, minimizing the environmental impacts. This not only reduces the workload on farmers, but also increases the overall efficiency of the farm operations. And precision harvesters. The another example is precision harvesters. These harvesters are also equipped with AI technologies have redefined the harvesting process. These machines can analyze the crop conditions in real time, identifying the optimal time for harvesting through advanced imaging and sensing capabilities. Precision harvesters can selectively harvest crops, ensuring that only the ripest produce is collected. This not only improves the quality of the harvest, but also minimizes the waste, contributing to sustainable agriculture practices. So it is we are well aware that in paddy fields, yeah, for example, paddy fields. Suppose if a farmer had 10 acres of land, or he used to take almost about a month from cutting to till the last grain comes to his house or the storage. But now the things have changed. Within a day or within a span of 8 to 9 hours, the entire 10 acres of land can be harvested with precision and without any wastages. So complete grains will be harvested and immediately it will be cleaned and only the quality seeds will be bagged. So such precisions we have received, and you just compare the time required. It's within a day and it used to take 1 month earlier case. So even if it was harvested over a month, still there were a chalky seeds, lot of stones and mud particles, everything used to be there in the seed packet. But now there is no scope for such things. Only the quality grains, completely filled grains will be bagged. So apart from those two tractors and harvesters, we are also using the robotic weeders. So with such a precision, only the weed crop will be plucked and without any damage to the crop or the main crop or the intended crop. So such a precision is there without damaging the main crop, it can pick the weeds only. Similarly, the planting machines with accurate speed, accurate spacing, without any damage, it can easily plant over an acres. Acres of area can be planted within no time. Similarly, the drone sprayers. So such a high volume and high accuracy of the spraying we can expect with the drones. So you just imagine a situation of a farmer who himself is spraying with a backpack sprayer. So it the speed of the spray varies from person to person. The capacity of a farmer to pump varies and the speed varies based on the climatic situation. If it is very hot sunny day, the farmer used to get fatigue very early. That's the health condition of the farmer, you just imagine. And whether the pest or disease is there on the particular plant, the spray solution goes out. But in case of drone sprayer, you just imagine the sprayer covers within no time. The spray can be completed within no time. Very accuracy of the spray. You can expect complete coverage of individual plant by running the drones over crop. Individual plant get completely covered with the spray solution, same size of the droplets, and moreover, we can put the sensors through which only the plant part which is affected by a disease can be spread, or only on particular area where the insect congregates. So only on that particular area we can concentrate and we can give the spray based on the sensors. So we can save the time, we can save the investment on the chemical, we can spray the, we can save the money on that. Moreover to that, we can conserve our environment. So there will not be any harm effect because we are spraying only on particular insect or disease patch and not to other parts, not on the soil. So the soil health is restored. Moreover to that, non-target or the beneficial organisms will be saved. So with such a precision, we can go for drone spraying technologies. So harvesting machines. So such a wonderful machines we are having now. Only they can segregate among the ripened and non-ripened fruits and can pluck only the ripened fruits based on the spectral images they are analyzing, and it can harvest over a large area within no time. So that is the advantage. So apart from agriculture, if you just look into the allied sector of the agriculture like livestock management, so we have wonderful tools for livestock management also. So the one is automated livestock monitoring. So here we can study the behavior of the animals with AI powered cameras and sensors which can monitor the behavior of the livestock, changes in the behavior of a livestock such as reduced activity or unusual movements can be early detectors of any health issues. So by just sitting at, we can monitor over the pregnancy period or the delivery periods, or if there is any ill case, we can usually monitor. If there is any itching or any pest on the body, we can, based on the movement of the animals or the behavior of the animals, we can watch. So such of the advantages we have by behavioral analysis. Facial recognition. So the artificial intelligence actively recognizes and tracks individual animals through facial recognition, particularly for identifying and monitoring specific animals for health and production purposes. So this is another advantage. Environmental monitoring. AI actively analyzes the data from sensors, monitoring environmental conditions in livestock facilities, such as temperature, air quality, and humidity to ensure that animals are kept in optimal conditions. So these things can be operated or applied in a small dairies as well as a very big dairies. So health and nutrition optimization. So health diagnosis is one of the important criteria in maintaining any livestock. So these AI algorithms can process the data from various sources, including blood tests, wearable devices, and images to diagnose the health issues in livestock. Early detection of diseases can lead to more effective treatments. So the another one is nutrition management. AI can analyze the nutritional needs of individual animals and create customized feeding plans. This optimizes the use of resources and improves the overall health and growth of the livestock. So based on the several factors or several variables, like whether it is a drought animal, whether it is a milching animal, so the age of the cow, the stage of the cow, and prevailing surrounding climatic condition. So what are the nutrition that is required? Whether it is a drought animal, the milching, it is a milching animal, the nutrition requirement is more. If it is a pregnant animal, it may be more. So based on the weight of the animal, so the weight gain, based on the regular monitoring of the weight gain, the nutrition condition or the nutrition requirement of the animal may change. So based on that situation and the season, so if it is rainy season, the water requirement of animal may be less. If it is a rainy season, summer season, the requirement may be more. And similarly, the green fodder, the requirement may varies. So accordingly, we can take a decision and according to that, we can feed the animal. So feed quality control. So it can also assess the quality of feed ingredients and adjust the rations accordingly, ensuring that animals receive the proper nutrients. So if you give the dietary plan or the nutrition plan, if you feed to the machine learning, and the ingredients which you are going to put, based on that the ratio will be calculated, and the exact the ratio of the inputs will be delivered, and according to that the nutrition will be given to the animal and the quality will be maintained. So similarly, the predictive livestock breeding. So here the several factors like genomic selection, reproductive management, inbreeding avoidance, such of the tools can be operated and give the good breed ultimately. So genomic data can predict animal traits like milk production, disease resistance, improving herd quality through selective breeding. So once the data is fed, the genetic line of particular breed, if it is incorporated into a particular system, then the track will be clear over the years. Even after 100 years, we can get back to the old data and we can make assess whether it is a pure breed or impure breed, or what are the qualitative changes that have happened over the years. So earlier, if it's the ancestors, how much milk was given, how many calves were given in that generation, or what can be predicted over these years. So like that, we can predict everything. So in case of reproductive management, artificial intelligence can help to determine the best timing for insemination or natural breeding. By analyzing the data on estrus cycles and other factors, it can increase the success rate of reproduction. So many times the farmers are not in a position to observe when the animal comes for heat. So he has to watch every day and he has to make prediction in his busy schedule. But if you apply these systems, then easily the machine analyzes the condition of the cow, and based on the estrus cycle the animal is giving, based on its ancestral data, it gives a exact date or a near to the truth data which the farmer can make use. So likewise, inbreeding avoidance can track the genetic relationship between the animals in a herd to prevent inbreeding and maintain genetic diversity. So one of the interesting field of artificial intelligence is apiculture management. So one of the interesting subject for me also, which I am working on this. So here for producing a good quantity of honey, good quality of honey, so a lot of factors are affecting our bee population, like climate change, humidity, temperature, ecosystem. Likewise, the pesticide, that so many factors are being affected, the bees are affected. So out of which the analysis we have to take and make proper management of our beehives. So just imagine a situation if a farmer is having either 100, 200, 500. See, there are farmers who are owning more than 2,000 bee colonies. A single farmer is owning more than 2,000 colonies. Suppose if you want to examine the bees, so there is a mandate that every bee hive has to be monitored individually. So to study the condition or to study the pest and disease occurrence, so a farmer has to look after each and every box, even if it is having one box or 1,000 box. So you can imagine how much stress it is, how much time consuming, how much laborious, and many a times the bees may get rash. So these things may be there. So in order to avoid that, if you use this particular artificial intelligence and machine learning technologies, so just by sitting far away from a apiary, a farmer can take a better management practice rather than looking into each and every. Just by putting a third eye on apiary, he can simply relax at home and can take any decisions favorable for that management. So here we have the architecture of the beehive. So we have apiculturist, a bee farmer, or a person who is keeping the apiaries. He should have a mobile application. So the data collected through these applications will be transformed into the cloud system. So there the data will get analyzed. So based on the various sensors he applied in his apiary, the every data collected will be segregated, analyzed, and give the predictive decisions. So how it works exactly? So any device at a base layer, so the observation and data gathering. So sensing instruments and tools will be there like beak counter, temperature sensor, moisture sensor, or humidity sensor we call weight sensors. So there are various sensors which are deployed in the beehive. So all these sensors will give exact data, how many bees went out, how many bees came in. See, it is very crucial that the bee movement is very important step to monitor any healthy colony. So how many bees went out? How many bees came in? See, we say a standard minimum 13 bees has to come back with pollen in a minute. So there is a standard. So by deploying this counter, how many went, how many came in? At what exact time the bees started foraging activity? At what time the foraging ceases? So such data we will gather. What is the temperature outside the hive and inside the hive? So we are very specific. The bees are very specific rather than we. The bees are very specific for any brood development, very brood improvement, or whether they are going to store the honey or make the honey. The ambient temperature varies from 29 to 35 degrees centigrade. So whether the outside temperature is 40, 45, or 50, the in-hive temperature must be between 29 to 35. So these temperature sensors will give the right implication to a beekeeper that if the population of the bees, thermoregulatory bees inside the hive, if it is less, then the temperature they cannot maintain. Then in such a situation, additional support is required from a beekeeper by covering a cooler cloth or wet gunny cloth or shifting the colony to a much cooler area. So through that he can manage the temperature of the hive. So that sensation will be generated in his mobile app. By sitting at home, he can monitor a particular beehive, whether it is performing accurately or not, whether the thermoregulatory bees are in action or not, whether the temperature and optimum humidity is maintained inside or not. So by just sitting at home, he can gauge the situation inside the hive, faraway places, and he can give the proper instruction to a person who is looking them at a far off place. So just by doing that, he can maintain a healthy colony. So similarly, the weight sensor. So whether the bees are in action, whether these bees are collecting proper pollen, whether there is an improvement in the colony, whether there any improvement over the weight over the days, whether honey is properly being stored, and how much quantity of honey I can harvest at the end of the season. That is also one of the important data that is going to be generated. So by continuously monitoring a particular hive, so what is the quantum of honey I can harvest after particular time is being generated in this hive. So once this data is collected in a gateway layer, connectivity over several beehives, the protocol is generated, data aggregation, filtering and processing, data security, data management using so many protocols. The data will be segregated and sent in a form of a recommendation to a particular farmer or an alert. So, or by a notification, he can get. So once the data is generated, the cloud computing services provide public access and data sharing capabilities for the end users. Suppose multiple farmers are connected with a single operator, then individual data will be shared, and the person can monitor over large area of beehives. Suppose if the farmer, a particular farmer's bee colony is dwindling because of the disease. Take for example, Tay-Sachs brood disease has occurred in a particular farm. So if there are 100 farmers, the disease has occurred in a particular farmers. Just by monitoring the data of his farm, another farmer or neighboring farmer can get an alert that there is a disease incidence or there is some mistake with the bee management. So that this person will get clue that how he has to monitor. Suppose if he is exchanging the bee colonies, so he will get an idea not to get exchanged. So likewise, and what are the how much quantity of honey is being generated? Suppose if the farmers are in a collective group, like say for example, farmer producer organization, FPO. If hundreds of farmers are there in an FPO, the FPO CEO can get a better information how much quantum of honey is being generated out of my 100 farmers. So how much quantity of honey I can prepare the marketing linkage. Suppose if there is 100 quintals of honey I am getting, so for 100 quintals of honey, how much quantity of honey I have to sell in bulk, how much I have to go for processing and bottling. So likewise, the management decisions he can take up. Suppose if there are, if his expectation is, or if he has demand for 4 tons of honey. Suppose if there in that particular 100 farmers group, there is 25% of the 25 farmers colonies are being affected by particular disease, then the expected production may decrease by 25%. So the administrator will get an idea how to make up that 25%, either by outsourcing or by increasing the price and collect from the local farmers, or he has to make another 25 members as a group. So likewise, administrative or management decisions also can be taken with this. So Beehive online apiculture management system with a mobile application will be developed. So major parameters of precision apiculture, like temperature, humidity, hive weight, video and audio recording. So there is very interesting fact with video and audio recording is there is a crying of bees during different stages. So the sound, the voice they make during swarming is different, during a pest attack is different, during any change, abnormal changes in the surrounding situation, such a situation, the voice will be different. So by analyzing these screaming voice of bees, the administrator can take a right decision. Suppose if it is a sound from swarming bees, if the swarming season is nearby, then he has to observe the bee colonies and remove the queen cell, or he has to take a division of the colony. So likewise, the management practices he can implement just by looking at the app or just by listening to the audio voice. So similarly, the videos, in-hive videos or out-hive videos, so he can take a decision. Likewise, and in and out activities, whether the bees are moving properly, or is there any hindrance in the movement or delayed movement, or if the bees once they go out, if whether they are taking a lot of time to come back. So that gives a clear indication that whether the foraging plant is nearby or far off place. So if it is far off place, if the bees are taking a lot of time to move, then the beekeeper can take a decision to shift his hive to a nearing forage site. So if the forage is coming very fast, if the pollens are coming very fast, if the bees are returning very fast, then he can think of giving more number of supers. So they're all based on the data he is going to get at a single step. So these are the some simple temperature and humidity sensors. So this gives a clear picture on food consumption, start of brood rearing, pre-swarming state, death of the bee colonies, brood volume and winter cluster volume. So there are several factors which a particular beekeeper has to monitor to get a quality and quantity of honey. So these are all the parameters which he is going to get the information. So similarly, the hive weight. So by just putting these sensors of weight, he can predict honey production, pre-swarming status, pollen and nectar storage, colony population, brood development. So these are the parameters or the points which the farmer gets from far off place. Audio and video recording. These are the equipments which are deployed. Pest and disease detection, early swarming, foraging activities, stress level. So just by putting the video cameras in front of the hive or inside the hive, he can detect the congregation of the bees inside hive, whether they are making any abnormal activities inside the hive, or whether they are pulling the queen out to take out for So just by sitting at home, he can watch whether the queen is properly laying egg or not. If she has stopped old position, then he can really think if the population is good, if the forage is good, then he can easily think the queen is ready to depart the colony. So there is a swarming. So it is a swarming alert. So likewise, he can make several decisions. So stress levels. So based on the food storage inside the colony. So usually in all the frame, there will be certain quantity of the food is stored. So just by observing in a place, he can gauge whether the food store is good or bad. So based on that, he can take a decision whether artificial feeding is required or not. So in and out activity. So we can study the peak activity period, start and end of the activity, influence of external parameters, availability of food resource, detect robbing, loss of honeybees. So is there any loss? So we can study, suppose if there are 500 numbers of bees went out, whether all 500 came back or any death outside. So if it is normally, if there is in a normal course, if it is 1% or 2% death, it's okay. If it is a exorbitant number, then the beekeeper has to take decision. Is there any toxicity in surrounding areas or any heat? So lot of reasons will be there for the bee death. So he has to monitor all those factors and give a good management. So the final is supply chain and logistics. So very important AI for harvesting and sorting. So robotic harvesters. So in harvesting, AI-powered robots with computer vision can instantly identify and harvest ripe fruits and vegetables. This lowers the need for physical labor and speeds up the harvesting process. So take for example, apple. So in a bunch of apple, only one apple is ripened at a time. So even though there are 5 to 6 apple in a bunch, only one apple is ripened and others are in various stages of ripening. So if our eyes only will cheat us whether it is ripened or unripened just to segregate between if it is 100% ripened and 90% ripened. Between two, many a times our human eyes will be failed, but not the robot eyes. So once you feed the algorithms, then they can easily detect whether to whether the fruit is completely ripened or semi-ripened. So based on that quick decision, they harvest only the ripened fruits, leaving alone the unripened fruits. So similarly, the sorting and grading. So these algorithms can sort and grade the agriculture products based on various criteria such as size, color, and quality. Automated sorting systems driven by AI ensure consistency and accuracy in the sorting process, leading to higher quality of products reaching the market. So nowadays, many of the super bazaars, they have up to these systems, and they are segregating and sorting this kind of many big markets have deployed this system and making their work very easy, and high quality products are being there in the market. Real-time monitoring and tracking. So these IoT sensor and AI analytics, the sensors placed on vehicles and containers and packages collect the real-time data on temperature, humidity, and location. So these algorithms analyze this data and ensure goods are stored and transported optimally. So several perishable products are there which are being transported from one location to another location. So many cold storage vehicles are also there. Many a times these cold storage equipments are not properly working. So in such situation, farmers are not known whether what is going inside the containers. So in such situation, deploying these equipments or sensors on those logistic vehicles, so they can collect all the information available inside the container and they can take proper decisions. So because of this, my goods are traveling safely or it is very unsafe. So there is some mistake with the cooling equipment. So likewise, they can take a decision and immediately inform the concerned person to correct it. So predictive maintenance. So artificial intelligence can predict the equipment failures by analyzing data from sensors and machinery. This allows the proactive maintenance, reducing the downtime and ensuring that vehicles and machinery are in optimal working conditions. So very important in produce transportation, route optimization, one of the wonderful application of the artificial intelligence. So several of us, we have already known this, how best we can use this. So our Google Maps clearly gives where the traffic, how the congestion is there, whether the traffic is clear, how best we can travel, at what time we can reach the spot, at what speed we have to travel. Everything will be designed and prediction will be done by algorithms, traffic patterns, weather conditions, historical data to optimize real-time delivery routes. This minimizes the transportation costs, reduces the fuel consumption, and improves the delivery time accuracy. So in our day-to-day life also, we have faced this. So this system clearly gives the alternative routes, best routes. So we have faced, we have seen, and we have enjoying this application in our day-to-day life also. But this application with respect to agriculture produce gives wonderful information how best our goods can be transported with a stipulated time with good quality. So optimization of distribution. So here demand forecasting. So artificial intelligence analyzes historical sales data, market trends, and other variables to forecast demand accurately. This enables the businesses to optimize inventory levels and avoid overstocking and understocking of the products. So nowadays, all the big markets, they have very well connected, all the local networking there. So where the demand is there, for which product is there, what should be the quality of that particular product. If the quality is this A grade, B grade, C grade, so for which market we can post that produce. Suppose if it is under quality, for which product, for which market it can up. So likewise, the decisions can be taken by sitting at farm level itself. So based on the conditions, it also gives the allocation, or the it gives also gives the notification for the buyers. So if you are expecting this particular quality of the produce, so here you can go. So this particular farmer is growing this quality of this produce. Take for example watermelon, or orange, or tomato, or brinjal, whatever the produce it is. So the quality you are expecting is available with this particular farmer. Suppose if you want this much of quantity, this particular farmer is having. So this will be the transport. So you have to incur this much expenditure on transport by if you purchase from this farmer. So if he is the nearest farmer, he is the longest distance farmer. So likewise, all the details can be gathered within a fraction of seconds. So likewise, the farmer or a buyer can take simultaneous decisions: whom to sell, what to sell, where to sell, how much to sell, at what price I have to sell, at what price I have to buy. So all these decisions will be done within fraction of seconds. So warehouse management. So AI powered systems optimize warehouse layouts, automated inventory management, and enhance order picking processes. This leads to faster order fulfillment, reduced errors, lower operational costs. So this is very much evident in warehouses, the two which are built with all the art state of the art technologies. So we can easily expect our produce is in safe hands. Similarly, the dynamic pricing. So this is one popular word every day we are listening, either with respect to the earphone, that is the aeroplanes, or the flights, or the with premium quality trains. So both are using this dynamic pricing technologies. Nowadays, even the bus operators are also using this dynamic price system. But in agriculture, these algorithms in real time actively analyze the market demand and competitor pricing. So this information is actively used to adjust prices dynamically, maximizing the revenue during periods of high demand and ensuring the competitiveness in the market. So just by a farmer in a remote village, if he gets the information on market price in the nearby cities, he can demand much higher price for his produce at the local market. So this has given Nowadays, all the farmers are very intelligent because of the system, and they are fetching very high price. If he is little tech savvy, we can call, or technology literate, we can all other word we can call. So then easily he can avail all these benefits. So this is how the system is operating. Impact of artificial intelligence and machine learning in the agro-food and the FMCG sectors. So all the FMCG are the food marketing, what the personas are there, they are classifying their requirements based on this artificial intelligence and machine learning technologies. From that places only they are sourcing, and they are getting good quantity or good quantity of commodities, like dairy industries, where this technologies is being used for lactose removal by milk. Bakery industry, they are using the robotic technology for all the purposes, starting from weighing of the atta to the end product and packing itself. Like beverage industries, where sensory estimation using e-nose and e-tongue. See, these are the new terms we are learning, e-nose and e-tongue. So for checking the smell or aroma of a particular wine and taste of a particular that wine. So earlier, the people used to hire people for these two purposes. Nowadays, without the intervention of any human being, the machines are giving very accurate data on the smell and taste. So the benefits of adopting IoT and artificial intelligence technology in agriculture. So as we are already well aware of these factors, like a reduction of risk in sales and business processes, deployment of predictive systems to create agile farming workforce, increased efficiency on land, minimized labor cost due to smarter technologies, smart agriculture decision making through data analysis, automated agricultural machines for improving the crop quality, limited use of pesticide and healthier soil quality. So these are all the benefits which we are deriving day by day in agriculture field by applying newer and newer technologies. So once again, the same. So by deploying this artificial intelligence, we are expecting higher crop yields, up to 15 to 20% increase by optimizing planting, irrigation, and pest control systems, enhanced resource management, optimizing water and fertilizer usage with real-time data analysis, 25% reduction in the water usage, 30% decrease in the fertilizer cost we can expect, improved market access, AI-powered platforms connect farmers directly with buyers, reducing intermediaries. So actually, the intermediaries are the real burdens for which so many acts have been brought. With all that, in Indian agriculture scenario, without intermediaries, no produce is buying and selling without them. So by applying the high-tech, these technologies, so we can reduce 40 to 50% of in our net income, and there is an increase in income. So all these things really will give a revolution to the Indian agriculture. Reduced risk. So it detects early signs of pest and disease via satellite, drones, and IoT sensors. 70% reduction in crop loss due to pests. Empowering smallholder farmers. AI-based advisory services provide tailored recommendation for small farmers, not only big farmers. Even it is applicable for small farmers, which is a very important factor. So generally, all the recommendations will go for a large farmers. Usually the recommendations will be keeping in eye with a large farmer. But even this technology can be applied for the small farmers also. There's a 25% increase in productivity within first years. Sustainable practices, AI-driven analysis promote eco-friendly farming with better resource management. 35% reduction in greenhouse gas emission. 20% improvement in soil health. See, there are several. So from starting from 15 to 70%, 80%, the report says. But personally, I'm very happy even if it is 10%, meager 10% increase or meager 10% decrease. So that will give a lot of impact on Indian agriculture. I'm not talking about advanced countries. I'm talking country like India, or which is a developing country, wherein which 5 to 10% deviation or increase or decrease, which is expected, will give a tremendous impact on farmers. So there are three successful public-private partnerships we are seizing in digital farming. One important is AI sowing app developed by Microsoft. So Microsoft and a local non-profit, non-governmental agriculture research organization, International Crops Research Institute for Semi-Arid Tropics, we call it as well known as ICRISAT, collaboratively developed an AI sowing app. The app is powered by Microsoft Cortana Intelligence Suite and Power Business Intelligence. The Cortana Intelligence Suite includes technology that helps to increase the value of data by converting it into readily actionable forms. Using this technology, the app is able to use weather models and data on local crop yield and rainfall to more accurately predict and advise local farmers on when they should plant their seeds. See, very important decisions. So here it analyzes all the data collected from the farm and local situation, everything taking into consideration weather forecasting models. So it analyzes all the local data and gives the exact accurate prediction. So when the farmer has to give soil. So in June 2016, a test pilot with 175 farmers was done in Andhra Pradesh. So the farmers benefiting from this application did not incur any upfront capital expenditure such as installing sensors in their field. See, otherwise individual farmers has to establish the sensors each 175 farmers. But here there was no need for installing in each fields or purchasing any smartphones, but merely needed a simple mobile device capable of receiving text messages. That was sufficient. So throughout the summer, the app sent 10 sowing advisory SMS to farmers in their native language. That is also very important. Many of our technologies are failing because of a farmer cannot understand the higher languages. Just for example, English. So he is much comfortable whether it is in Kannada or Telugu or Malayalam or Tamil. So whatever is mother tongue. So this app allows them to send voice message or text messages in local language. The sowing related text messages give crucial information related to planting times, weed management, fertilizer application, and harvesting. Alongside the app, a personalized village advisory dashboard was set up to enable local government officials to provide insights about the general soil health, fertilizer recommendations, and 7-day weather forecasts. So, if the officials gave that much information, then entire information was given to the farmer in the form of advisories. Higher yields from digital farming, an impact assessment of the 175 farmers in the pilot group reflected 30% increase. So by this helpful information in 2017, again, the project was expanded to 3,000 farmers, and because of the advisory, the farmers could harvest 10 to 30% higher yields per hectare. Wonderful achievement by ICRISAT along with Microsoft. The other one is price forecasting model. The lack of information about market conditions is problematic for smallholder farmers. They cannot go each day for the market and gather the information. Instead, they were relied on these applications. Farmers often feel compelled to sell their products to a middlemen who exploit this knowledge asymmetry to their advantage. India also suffers from inadequate participation of agriculture produce marketing organizations that could advise farmers on global projections of demand and supply. So with this context, Karnataka government and Microsoft, they have signed a MOU in October 2017, reaffirming their commitment to creating technology-oriented smart farming solution for farmers in India and declaring a plan to develop AI price forecasting model. The Karnataka Agriculture Price Commission, along with Microsoft, worked together to develop a multivariate commodity price forecasting model by combining AI, cloud machine learning, satellite imaging, and other advanced technologies. So how it predicts the prices? The model considers datasets on historical sowing areas, production yield, weather patterns, and other relevant information, uses remote sensing data from geostationary satellite images to predict crop yields at every stage of farming process. The resulting output from the model includes prediction about arrival dates and crop volumes, enabling the local governments and farmers to predict commodity prices 3 months in advance for major crop markets. With this information, the Karnataka government can more accurately plan ahead to set the minimum support price. According to Microsoft, the model is now scalable, efficient, and ready to be applied to other crops and to other regions around India. The summer 2018 harvest season was the first season in which the model was applied. So now the studies are being completed, and the expansion or scalability of this particular project is going on across the states. So once it is approved, probably shortly all of us can expect this app and predict the market price in and around the globe. The third one is Infosys Precision Crop Management. The population of India is continuing to grow at a rapid pace, which is placing an increasing demand on already inadequate food supply. Combined with growing climate change and shortage of arable land, the agriculture sector is faced with a challenge of exploring new ways of increasing the output. So for less, using the Internet of Things, Infosys has built a precision crop management test bed to address this need. This test bed will improve crop productivity through analysis of highly granular real-time sensor data. The test bed will initially focus on improving crop yield through the analysis of real-time data from environmental sensors located in commercial crop fields. So these three apps have been developed in relation to public-private partnership mode and being deployed in various sectors. So studies still underway. Probably in the days to come, we can expect these things. So now we have few challenges and ethical considerations like cost and investment, infrastructural barriers, technical expertise, employee resistance. So the data privacy and security. So who has to own the data? So one key issue is identifying who owns the data generated by artificial intelligence in agriculture, such as farm and crop data. Farmers, technology providers, and data platforms may all have competing interest in data ownership because huge or enormous data is being generated. But once the data is generated, who has to own? So to whom the data has to be addressed? So that is the issue. Data security, as more data is collected and exchanged, the risk of data breaches and cyber attacks grows. It is critical to safeguard sensitive agricultural data against unauthorized access and data theft. We are well aware next future war or the third world war, if it is occurs, it is in a biological form. So anybody, our enemies can do anything. So agriculture is such a vulnerable sector. If the data is breached out, if leaked out, then anything can happen in the form of biological. So we should be very careful in these sectors. Informed consent. Farmers and stakeholders should have explicit informed permission to use and share their data. Transparent data use policies and consent methods are required. So ethical use is environmental impact. We should deploy this technology to support sustainable agriculture practices while minimizing environmental harm and resource depletion. Fairness and bias. AI algorithms should be built and evaluated to eliminate bias and discrimination, especially in applications like loan approval, land appraisal, and resource access. So day to day, every day we are seeing in case of loan approval. So the bank middleman or the bank manager requires, or they come in a way while approving loans saying hundreds of excuses. Similarly, the land price appraisal. So if it is in a east direction, the price varies. West direction, the price differs. If it is in main road, the price varies. So accurate the information on a particular field will give the accurate price. So job displacement, implementing AI may raise concerns regarding job displacement in rural areas. We should consider strategies for retraining and upskilling the workforce. Say, take for example, if the farmer is having 10 acres of land, one machine can harvest within 8 to 9 hours. With the 40 to 50 laborers used to engage for harvest and threshing of the particular crop will be done with a single machine. So what 40 to 50 laborers have to do that? So where we have to deploy them? So that will be the big question. Responsible innovations. Developers and authorities must evaluate the ethical implication of artificial intelligence used in agriculture and mitigate any unforeseen consequences. So the future trends and innovations, rapid technological advances and are actively shaping the future of agriculture. Some interesting developments and innovations expected play a key role. So one such is blockchain and artificial intelligence in food traceability. Transparent supply chains. Blockchain technology combined with AI offers end-to-end traceability of food products. Consumers can track their food from farm to table, ensuring food safety and quality. See, for example, we go to several organic restaurants. Say they are 100% organic. But where is the proof? Suppose if you order one plate of idli, from where the rice used for that idli comes from, whether that farmer is very 100% organic or inorganic, who knows? If the technology is developed with a QR code, if you just scan the QR code provided along with the idli, you can easily scan that and you can refer to that farmer. I am having the idlis grown or prepared out of rice which you have grown. And farmer at the same time, farmer receives a message. The idli eaten by a particular person has been prepared out of rice which is grown by me. So it builds a consumer and a producer relationship along with the transparency. So I will be satisfied if I consume 100% organic, and the farmer will be happy if he will be feel happy. The person who eats my food or the produce which I have grown, he will be happy. So it is a mutual benefit. So similarly, the smart contracts on blockchain systems can automate transactions and agreements between farmers, wholesalers, retailers, reducing the bureaucracy and assuring fair pay for all stakeholders. Data integrity. Blockchain ensures the integrity of agriculture data, preventing tampering and fraud. AI system can analyze this data for insights, improving overall supply chain efficiency. So nowadays we are getting into multiple uh, security systems. So we need not worry much at this stage. So we are growing with the technology. AI embedded urban farming. So vertical farming is one such in urban farming, where the land is a constraint, where in which a farmer can or any consumer can grow his food in his own house. A vertical farming system, AI controlled vertical farms actively optimize use of space, water, and nutrients by tailoring environmental conditions precisely to plant needs. These farms can actively produce high yields in urban areas with a limited space. Similarly, the precision agriculture in cities, artificial intelligence sensors and the data analytics enable precision agriculture practices in urban settings. Real-time monitoring of crops and automated irrigation and data-driven decision-making improve crop health and productivity. Localized food production also helps to design and manage small-scale urban farms, reducing the need for long-distance transportation and promoting local sustainable food production based on the local needs. Access to technology in rural areas, digital divide. Rural areas may lack access to high-speed internet and other necessary infrastructure for AI adoptions. Addressing the digital divide is crucial to ensure that all farmers benefit from these technologies. Affordability may be expensive at this juncture, making it inaccessible to small-scale and resource-limited farmers, but initiatives to make technology more affordable and accessible are essential. So just similar to our smartphones, earlier days, even we had to use to pay for incoming calls. Nowadays, it is free of cost and unlimited calls. So similarly, the data and the price of the mobile cell. See, as the technology advances, it becomes more affordable. As number of consumers increases, the price automatically reduces. Education and training. Rural farmers and agriculture workers may require training to use AI tools efficiently. Providing training and support is essential for successful adoption. So some of the success stories, very important, and I am running out of the time, so I will be a bit fast. Suppose if there is anything, we will discuss on messages or at the end of this, or you can mail me at any point of time. So the Blue River technology, see and spray technology, one of the wonderful technology in agriculture which has developed by John Deere company, which has created a precision farming solution that distinguishes crops and weeds using computer vision and machine learning. The technology can recognize and accurately target the weeds using cameras and AI, delivering the pesticides only where needed. This eliminates the use of chemicals, lowers the expenses, and encourages better crops. Herbicide use was reduced significantly while crop yields were maintained or even increased. So one of the wonderful technology. The Climate Corporation, Climate Field View. The Climate Corporation, a subsidiary of Bayer, provides a platform that merges AI and data analytics to give farmers actionable insights. Climate Field View collects data from various sources, including sensors, drones, and satellites. It analyzes the data and gives farmer recommendations for planting, fertilizing, and harvesting. Farmers using climatic field view have reported higher yields and more efficient resource usage. Similarly, IBM Watson Decision Platform for Agriculture. IBM Watson Decision Platform for Agriculture includes weather data, IoT sensors, AI, machine learning to provide farmers with predictive insights and suggestions. The platform provides personalized planting, irrigation, and harvesting assistance by analyzing weather forecasts and soil conditions and crop data. Farmers who use platform report higher yields, lower water usage, and better crop quality overall. So all those three developments are very wonderful innovations in the field of agriculture. Only after sufficient fine tuning, if everyone gets that benefit of those three, or maybe much more in the future days to come, will definitely give a new path or a new regime shift in the path of agriculture, Indian agriculture in specific. So future potential in precision agriculture, predictive analytics, AI-powered robots, personalized recommendations. So all these factors are very much important in the field of agriculture for giving any factors driving AI growth or limiting are the bottlenecks we can call population growth and food demand, limited resources and climate change, rising labor cost and shortages, data deluge and advanced analytics, technological advancement and affordability, consumer demand for sustainable agriculture, partnerships and collaborations. So to conclude, artificial intelligence in agriculture is becoming increasingly important as it leads to more efficient and sustainable farming practices. AI can be applied to precision farming, crop management, livestock monitoring, and supply chain optimization. Through data-driven decision-making, this technology has the potential to revolutionize agriculture by raising crop yields, reducing resource waste, and promoting environmental conservation. With ongoing advancement, AI is expected to improve food production, further enhance resilience in the face of climate change, and ensure a more sustainable and prosperous future for agriculture industry. Thanks for patience listening and welcome for any clarifications required.